The last thing that we're going to talk about in this section 11.1 on vectors in the plane is what's called a process of normalizing a vector. It's kind of an odd phrase, but that's what we say, normalize a vector, which means, as we say here, to find a unit vector in the same direction as the given vector. To find a unit vector. Well, first of all, it's not like a search, like go out and find. There's a formula for this. The term unit vector simply means a vector of length 1. And so idea-wise, like the formula's there, you can see it. I just want to give you the idea here. We'll do this, normalize this vector here in a second. So the idea is we have 1520, just kind of a rough sketch here without a scale or anything. Be a vector like that. So to normalize this vector, this kind of odd phrase, means to find, which is just by a formula, a vector which is, it'd be kind of a teeny tiny thing down here of length 1 in the same direction as that vector. So the vector 1520 is big long vector there. Its length I don't know, but we will figure that out in a moment. And to normalize that vector just means there's a formula to find, and the formula will give us a little blue vector of length 1 in the same direction as the original 1520. So that formula I've mentioned a few times is, I'm going to get rid of this rough little sketch, but keep it in mind as we go through the math here. The formula is this guy over here. So if we have a vector AB, what this formula is saying is if we divide by the length of AB, the length of itself, we get what we want in terms of normalizing a vector. That expression gives us a unit vector, meaning a vector of length 1 in the same direction as A comma B. And so part of this is doing the length, the magnitude of the given vector. So we have to do that, which is formula from before, the square root of 15 squared plus 20 squared, which is the square root of 625, which is 25. So that's the length, that's the denominator over here. And so what we need to do now is take the given vector, A comma B, which is 15 comma 20, and divide by the length that we just calculated of that vector, 25. Now what it even means to divide a vector by a number is similar. It really comes from the same thing as scalar multiplication. So dividing by 25 is the same as scalar multiplying by 1 over 25. So in a nutshell, what that means is divide both coordinates of the vector by 25. So we have, this is 15 over 25, comma 20 over 25. So that's equal to 3/5, comma 4/5. So that would be that little blue vector in the diagram from before, where 1520 was the big long vector, and to normalize it means plug into this formula, come up with this vector, and the significance, or what that vector is, the blue vector here, is a vector that is in the same direction as 1520, the original vector, but the blue vector 3/5, comma 4/5 has length 1, magnitude 1. So that's all that normalize a vector means. And I'm going to do one more here. You'll find one on the homework, similar to example 9. Vectors of length 1 can get kind of messy. You know, I did this example here, and I chose 1520 and 3, 4. You could see within there is like the 3, 4, 5 right triangle, and I just worked with nice numbers purposefully to come up with a neat-ish answer. But vectors of length 1 can get pretty messy with numbers. And you'll find one like this on the homework, v is given negative 6.3i, or something like that, plus 3.1j. And so typically what you would do is you have those decimal numbers, you kind of go into the formula and go ahead and do it, much like you just did the previous one, but round the answers somehow. And that's not what WebAssign wants us to do, I believe. I say I believe only because I see two different things on WebAssign in terms of the expected answers for questions like this. And so I'm going to go ahead and do it this way, get exact answers, no rounding involved. And this should work out fine for you. Follow this model for this particular problem. But if for some reason it doesn't, let me know. Okay, so to get an exact answer though here, with no rounding involved, with square roots of this and that and stuff like that, the way that you would go is you have to pull a little trick right at the beginning, and you don't want to work with those decimals. So you're going to change the problem. To integers only. So I wrote v with a little mark there for prime. V prime is a different vector. I just changed this vector quite a bit, right? It was negative 6.3 before for the first coordinate. Now it's 63. So I multiplied them both by 10. So I changed the vector, but now I'm going to go through the unit vector process, the normalizing process with this new vector, and that will get us a unit normal vector in the same direction as v prime, which will also be a unit normal, that will get us a unit, leave out the word normal there, that will get us a unit vector in the same direction as v prime, which will also be a unit vector in the same direction as v. So, and the reason for that is that v prime is a multiple, a scalar multiple of v. So it's probably easiest to understand with a picture. We have a problem with a vector v, and that is to find the unit normal vector, which is going to be something like that at the end of the day, of length 1. But v is kind of messy numbers with decimals, so I multiply them both by 10 to clear the decimals. So when I do that, I'm going ahead and changing from v to v prime. Then I'm going to normalize v prime, which will get us to this unit normal vector of length 1 in the same direction as v prime, which is also in the same direction as the original v, and unit normal with exact values for answers instead of any rounding involved. Okay, so let's go for it here. So what we have to do is calculate the magnitude or length of v prime. I'm going to work with v prime from now on. So that would be negative 63 squared plus 31 squared, all that square rooted. And that would be square root of 4,930. And our answer then for a unit vector in the same direction as v is v itself, a v prime here, I'm working with v prime, so negative 63, 31 divided by the length of v prime, square root of 4,930. So that's negative 63 over the square root of 4,930, 31 over 4,930. And as I said, I'm looking in two different places on WebAssign, and they don't exactly coincide. But in terms of the answer that I see, type of answer for a problem like this, that's what the type of answer that you should input. So, it's not a terribly hard problem. It's just probably not what you would think to do with the original numbers involved. It's basically to clear decimals first, and then do this formula in the blue cloud up here. And also, what's kind of curious is even though they want you to do that, they do seem to accept radicals in the denominator. Okay, so anyway, it's a little wonky, the answer to that one, but knowing that there's this process to come up with a unit vector in the same direction as a given vector is sometimes just a trick to help get some kind of problem solved. Okay, so that's it for section 11.1 on vectors in the plane. And make sure that you tackle the homework on WebAssign for that section.